Hi there, my name is Mike Schlosser. This presentation uses geospatial slope analysis techniques to evaluate a proposed development project for certification under the LEED for Neighborhood Development Rating System. Leadership in Energy and Environmental Design, or LEED, is a certification program that encourages the adoption of sustainable design, construction, and operation practices as applied to buildings and communities. LEED ND encompasses many categories, ranging from habitat protection to urban density, all of which are intended to promote a green approach to community development. One category in which points can be accumulated towards LEED certification is in the area of steep slope protection. Here, the objective is to minimize erosion to protect habitat and reduce stress on natural water systems by preserving steep slopes and keeping them in a natural, vegetated state. One option in this category requires that project sites avoid disturbing areas with slopes greater than 15%. A quick way to check whether a proposed site qualifies for maximum points under this option is to superimpose a 2D CAD drawing of the site and a 3D digital elevation model, or DEM, and then perform a simple thematic map based on slope. Let's see how this is done. So here we are using AutoCAD Map 3D 2010. First, let's take a closer look at our study area. Here's our proposed site. What we'd like to do is connect to digital elevation model data, a DEM file. By connecting to the data, we can avoid the import-export process. So let's add that connection to our existing parcel map, and we can see the digital elevation model in green. Let's just zoom to the extents of that model. All right, now, in order to see the parcels superimposed on our digital elevation model, we simply change the draw order. Now we can see our proposed site as well as the surrounding parcels. Let's take a look at stylizing our digital elevation model. We can stylize by theming the model according to different properties, such as height, or slope, or aspect. Now, we're interested in slope, so let's choose that and create one category since we're only interested in those slopes that are greater than 15%. So we'll select that one. We'll leave the style ramp as it is, which allows us to choose colors. And let's take a look at the band detail. Here we can see we currently have one category that goes from 0 to 90 degrees. But we're interested in 15% slopes. 15% slope is the same as 8.5 degrees. So I'm going to enter 8.53 degrees here. Apply that. And let's change the color for anything greater than 8.53 degrees slope, like so. At this point, we can also change the legend. The legend, I want to put down less than 15%, and then change this one to greater than 15% so it's easily identifiable. All right. So now you can see how the site is superimposed on a digital elevation model where all the red areas indicate slopes that are greater than 15%. We can also take a quick look at this in 3D to see what the lay of the land might really be like. I'm using a vertical exaggeration of 3, so I've scaled the height by a factor of 3. I'm choosing an orientation that makes it easier to view my site. I zoom in on that, and there we have a very quick way of analyzing a site's impact on steep slopes. In summary then, geospatial analysis in CAD and GIS integration helps in the creation of better, more sustainable neighborhood developments. Furthermore, quick and easy workflows, such as the one just demonstrated, means that more design alternatives can be evaluated against LEED for neighborhood development criteria for the selection of the best design option. Also, we used AutoCAD Map 3D, an engineering GIS platform that integrates CAD and GIS data and performs spatial analysis. For more information, please visit www.autodesk.com.